Picture this, a planet almost exactly Earth's size, with flowing rivers, oceans of liquid water, and maybe even life. Until one day, it all went horribly wrong, turning into a 900-degree furnace where even lead would melt on the surface. This isn't science fiction. It's the story of our neighbor Venus, and it holds a terrifying warning for us. What if I told you that Earth has a twin, not an identical twin, but a cosmic sibling that started out almost exactly like our world? Venus sits in what scientists call the Goldilocks zone, the region around a star where conditions might be just right for life. It's about the same size as Earth, made of similar materials, and even has a similar internal structure. But today, Venus is literally hell. Surface temperatures hot enough to melt lead, crushing atmospheric pressure 92 times stronger than Earth's, and sulfuric acid clouds raining down acid. So what went so catastrophically wrong? The answer lies in something called the runaway greenhouse effect, and understanding it could be the most important lesson humanity ever learns. The story begins with starlight. Like Earth, Venus receives energy from the sun. Some of this energy gets reflected back into space, while some gets absorbed, warming the planet. The planet then radiates heat back out as infrared radiation. Here's where greenhouse gases come in. These gases, like carbon dioxide and water vapor, are transparent to incoming sunlight, but opaque to outgoing infrared radiation. They trap heat, keeping the planet warm, a natural and essential process. On Earth, this greenhouse effect makes our planet habitable, keeping average temperatures around a comfortable 15 degrees Celsius instead of a freezing. But on Venus, this process went completely out of control. Scientists believe Venus once had oceans. Early in its history, it was probably much cooler, with liquid water on its surface. But being closer to the sun than Earth, Venus received more solar energy. As the sun warmed up over billions of years, Venus's oceans began to evaporate. Water vapor is an incredibly potent greenhouse gas. More water vapor in the atmosphere meant more heat got trapped. More trapped heat meant more evaporation. More evaporation meant even more water vapor trapping heat. This created a powerful positive feedback loop, a vicious cycle that kept amplifying itself. The planet kept heating up, the oceans boiled away completely, and all that water vapor entered the atmosphere. Then came the real nightmare. In the upper atmosphere, sunlight broke apart the water molecules. The lightweight hydrogen escaped into space forever, while the oxygen reacted with rocks. Venus lost its water permanently, but the carbon dioxide that had been dissolved in those oceans and locked in carbonate rocks, that was now released into the atmosphere in enormous quantities. Venus's atmosphere is now 96% carbon dioxide, compared to Earth's 0.04%. The greenhouse effect became unstoppable. The surface temperature skyrocketed to 465 degrees Celsius. The atmospheric pressure became crushing. Any hope of life vanished. This is the runaway greenhouse effect in its most extreme form, a climate disaster of planetary proportions. And here's what should really keep you up at night. We're currently conducting a massive experiment with Earth's atmosphere. By burning fossil fuels, we're pumping billions of tons of carbon dioxide into our air, the same gas that turned Venus into a hellscape. While Earth will never become exactly like Venus because we're farther from the sun, we could trigger a less extreme version of this runaway effect. Scientists worry about reaching climate tipping points where warming triggers natural processes that release even more greenhouse gases. Thawing permafrost could release vast amounts of methane, another powerful greenhouse gas. Warmer oceans absorb less carbon dioxide. Dying forests stop absorbing it. We could set in motion feedback loops that we cannot stop. The story of Venus isn't just about a distant world. It's a cautionary tale written across the cosmos. It shows us that planets can cross a threshold from which there is no return. When we look at Venus, we're seeing what happens when a climate system completely breaks down. But there's also hope in this story. By understanding what happened to Venus, we gain crucial insights into how to protect Earth. We can recognize the warning signs. we can understand the delicate balance that keeps our planet habitable, and we can make choices to maintain that balance. Venus stands as a permanent reminder in our sky, a beautiful evening star that hides a terrifying secret. It's proof that planets aren't guaranteed to stay habitable forever. The conditions that support life are fragile. The runaway greenhouse effect turned a world that might have been lush and alive into a scorching wasteland. As we discover more exoplanets around other stars, many of them so-called super-Earths that might be Venus-like, this understanding becomes even more critical. Which of these worlds are truly habitable and which are cosmic traps? The lesson from Venus is clear. The difference between paradise and hell can be surprisingly small. What do you think this means for humanity's future? Could we ever trigger our own version of Venus's fate? Drop your thoughts in the comments below and follow for more mind-blowing cosmic stories.